Hi, everyone. Our next speaker moonlights as a manufacturing engineer, helping her friends get their products made. She also writes extremely eloquently about the subject. She's a firm believer in small-scale manufacturing and custom manufacturing, and has made the Leave Me Alone sweater. Please welcome to the Hackaday Supercon stage, Ruth Grace Wong.
Thank you so much for the introduction. So this is me. I have a day job doing software at scale as a site reliability engineer. And for the past 2 years, I've been writing about manufacturing. So that means interviewing manufacturers, as well as visiting factories, and also kind of making things in my spare time, including the Leave Me Alone sweater, to get that physical intuition of how stuff is made. And only recently, a few months ago, I've been able to actually get a part-time job helping my friend out as a manufacturing engineer. So I was actually replacing their full-time engineer as a part-time engineer, so it's been a bit of a whirlwind, but super fun, and I've been learning a lot. So in this talk, I have some firmware from a Chinese contractor that we work with. We've got two goals. One, we're going to find a bug in the code. And then the second thing is, as we go along, we'll learn about some basic firmware concepts. And the idea is to give you some confidence where if somebody gives you a bunch of firmware code, you can approximately figure out what's going on and still be able to work with it, even if you haven't had experience with firmware in the past. So this is the system that we're working with. The company makes hydroponic products. It looks like some kind of Japanese maple in that one. We have, so there's the microcontroller, which is kind of the brain of the system. We've got a fan for air circulation, a pump for watering the plant, and then LEDs. And then also we have an LCD display and buttons so that you can schedule what time you want the fan, the pump, and the lights to go on. And the bug that we have is that, in this case, our medium and our low fan settings were the same when they were supposed to be different. So I asked our engineer at the factory for the code, and this is what I got. We're going to ignore all of the files except for the C files, because those are the ones that have the human-readable C code. There are also header files, the .h files, which kind of define the way that you would interface with the code. And then the rest are various compiled files, and we're just going to ignore all of those. So this is what the interface looks like when you're selecting the fan setting. And so I figured that would be a good place to start in the code to look for this, because I know it connects to the fan and how the fan works in the code. And so we have inside the interface.c, if you look around, you find exactly that. And so you can see that the fan mode depends on flag 7. So when flag 7 is equal to 1, the fan mode is high. So the selection is that asterisk. And then when flag 7 is 2, the fan mode is medium. And when flag 7 is 3, the fan mode is low. So maybe a little bit opposite what you'd expect. The higher number is the lower setting. And so knowing that this is what flag 7 is, we're going to go searching in the code for flag 7. And it shows up in two files. It shows up in key.c, and it also shows up in main.c. So let's look at key.c first. And the first instance of flag 7 in this code is this this if statement. And so if you actually translate the Chinese comment here, so the code is very well documented, but in Chinese, it says add key and shift settings. So what this part of the code does is it checks, if you press the up button, it checks to see which display you're on, and then depending on which display you're on, it increments the appropriate counter. And since there's only 3 settings for fan, if you've incremented all the way to 4, it resets it back to 1, so it wraps around. And similarly, in key.c, the next instance of flag 7 is here. This is the reduce key and shift key settings. So this is when you press the down button, the same thing happens. It checks which screen you're on, and then depending on the screen, it decrements a counter. And then it wraps around so that if you've decremented past 1 to 0, it wraps back up to 3. And so you may be wondering at this point, this is a little bit convoluted. And the reason behind that is we don't actually have a firmware engineer. We have a PCB engineer with an electrical background. And he's been tasked with also writing the firmware without any formal software training. So he knows enough code to prove that his PCB works, but he hasn't learned anything about like software architecture and modularity. And it's not obvious to the average person that making the hardware and programming the hardware are two different skill sets that you might need different people for. Similarly, it's not always obvious to the people who run the factories. So moving on to main.c, this is the first instance of flag 7. And if we translate that, it is indeed the fan working mode selection flag. So that's good. We were correct in thinking that. The next instance of flag 7 in main.c is this SA data function. And if you translate the comment in Chinese, it says power off data to 24C02. And if you Google what 24C02 is, it is an EEPROM, so an electrically erasable programmable read-only memory. So something to know about firmware is that there's two types of memory. You've got flash memory, which is kind of analogous to RAM in a computer. So flash memory doesn't persist after you turn the device off. And then you also have electrically erasable programmable read-only memory, aka EEPROM, and that's kind of analogous to hard disk. So it will persist after you turn the device off. And of course, we need this for our settings because if you restart the device, you want it to remember what setting your fan was on. So it's saving the fan setting here. So this function should be save data instead of SA data. Similarly, we have a read 24CO2 function. And you can notice that there's a number here. This is 248, which is the same as the previous one. So the 248 is actually the address of the place that the data is written to the EEPROM. And in this particular EEPROM that we have has 256 spots that you can write an 8-bit number to. And so the fan setting is being written to spot number 248. The next thing that you see in the main function is the main loop. And so this is an important thing in firmware because this is where the code always starts executing. So the main loop kind of runs over and over, and it's always checking to see what needs to be done. And the only instance of flag 7 inside the main loop is this section over here. If we translate the comment over there, it says new 24CO3 needs to be reinitialized. So this is, if you have bought the product and you're turning it on for the first time, then the EEPROM is going to be empty, which means that we want to have some default factory settings that make sense. In this case, the default factory setting is low for the fan, so flag 70 equals 3 means low, because if you've got a seedling in there, you don't want it to be like blown around. And then it's going to save that to the EEPROM right after it sets it. So the next thing inside main.c, so we're outside of the main loop now. This is not part of the main loop. This is a timer interrupt. So in firmware, there's two types of interrupts. You can have an external interrupt, which is like if you press a button, then interrupt whatever's happening and then run some code to respond to the button press. You can also have an internal timer interrupt, and this is when a timer has counted to 0, then fire this code. So in this case, the TH1 in the code is the high value for the timer. TL1 is the low value for the timer, so it's always counting down from the high value to the low value. When it triggers, we are disabling the ticking of the timer by setting TR1 equals 0, and then after we finish running this code, we turn the timer back on with TR1 equals 1 at the end. And then within this code, there's another time counter, which is the time variable. And every time this code is triggered, the time variable is increased. And if it gets up to 40, it's reset back to 0. So time is always counting from 0 to 40, and then 0 to 48, and so on. All right, and then for the next part of the code, the thing that you need to understand is PWM. Does anyone know what PWM stands for? Shout it out. Pulse width modulation. Right, so PWM is kind of like turning something on and off really fast. So if you want the fan to be at 100% power, you just have it on all the time. And then if you want it to be on at 50%, you could turn it on and on really fast, and then it would effectively be at 50%. So that's kind of what's happening here. So if flag 7 equals 3, which is the low setting, when the time is between 0 and 14 out of 40, so that's like a bit over a third of the time, 37% of the time, we've got PWM set to 0. Now, you would think that PWM set to 1 means on and PWM set to 0 means off, but it kind of depends on like the way that the thing you're working with is implemented. And in this case, if we know that it's the low setting is 37% something, it's probably 37% on and then like the rest of the time off. So PWM equals 0 means on, counterintuitively. And if you look at the next part, which is flag 7 equals 2, which is the medium, that's not my time, is it? No, okay. There's the bug. So the medium setting is exactly the same as the low setting. And so that's our bug. And if you look at the high setting, when time is less than or equal to 40, which it always is, it's always counting between 0 and 40. PWM equals 0, so it's on. So the high setting is on 100%. The low setting is on like 37%, about a third of the time. And then for the medium setting, so the translation of that Chinese, by the way, is exactly what the name of the function is. And for the medium setting, if we make it between 0 and 24, then we have about 2/3 of the time the fan is on. So now we fixed the bug. Hooray. So just a quick summary of the things learned. If you ever want to refer back to these slides, these are the things we talked about. So tip number 1, Google your component names, because you can find out what they are just by like Googling, 24CO2. We saw some variables, flag 7 being a variable. It could have been more appropriately named, but sometimes you get things and sometimes you don't. We saw some case statements and if statements where, depending on the value of flag 7, something happened. We learned about different types of memory, so EEPROM, which survives power cycle, and flash, which does not. We learned about different types of interrupts, external and internal. We learned what PWM is, and we also learned about the main loop, which is where the code starts executing. A couple caveats: if you are ever in a situation like I was, where you don't know anything about firmware and you have to go look at some firmware code, setting up your tool chain is a lot of work. So if you're somebody who uses Arduino, Arduino spoils you because it's so easy to set up compared to anything else. I've been working on this for maybe a month and a half, 2 months, maybe once or twice a week, and I've only just gotten to the point where I've finally set up the software so that I can compile this code properly and I can download it onto the microcontroller properly, and there's no mistakes with the code is too big for the microcontroller or other things that go wrong. So if you're working with a project for the first time, I think 50% of the work is actually setting up the tool chain if it's not Arduino. And then the other caveat is that there's a lot of people who write production firmware code that are not necessarily firmware engineers. So if you are looking at some code and you're like, that's weird, why are they doing that? This might be the reason. A few acknowledgements. So thanks to the Aqua Design Innovations team for letting me work with their products. And also thanks to Chao Don, who has been teaching me everything I know about firmware and helping me a lot with this talk. Cool. And I guess I'll be taking questions, and I'll probably be down there. Thank you very much.